Good morning to everyone. I think in the last class we discussed line integrals. So now we are going to discuss the important theorem, Green's theorem. Green's theorem. In a plane. So to solve the problems in Green's theorem, Green's theorem or Stokes theorem or Gauss divergence theorem, there are three theorems. So you should know the integration, especially you studied in the first semester mathematics. So that is a double integration and triple integration. Okay, just okay. Anyway, I will recall those things. So maybe you can also just if you have a first semester math, I think you don't have the first semester mathematics book. Okay, suppose if you have, I think I shared a Virarajan book. So in that Virarajan book, you have integration also. So please check it. Otherwise, inform me. I will send you semester one book. Okay, so you can check double integration and triple integration. Okay, so now write down the statement. If C is a simple closed curve, this is the statement of Green's theorem. If C is a simple closed curve, enclosing a region, enclosing the region capital R in the xy plane, in the xy plane, and P of x comma y Q of x comma y and its first order partial derivatives and its first order partial derivatives are continuous in capital R. Then integral over a closed curve C over a closed curve C pdx plus qdy pdx plus qdy is equal to double integral over R dou q by dou y, dou q by dou x minus dou p by dou y into dx into dy. The left hand side you have a single integral around a closed curve C. Right hand side is double integral over the region R. Okay, here where C is capital C is described in the anti-clockwise direction. Anti-clockwise direction. Okay. This is somewhat important. That's why direction is important. So anti-clockwise direction. So this is the statement. Okay. So to evaluate the right hand side, you should know the double integral. So okay, I think here usually the right hand side is little bit easier than the than the left hand side. Even it is a double integral, calculation of double integral is little bit easier than the single integral. You can feel if you solve the problem. Uh, when we solve the problems, okay, you can understand why I am telling like this. So first of all, verify Green's theorem in a plane with respect to interval C x square minus y square into dx plus 2xy into dy, where C is the boundary of the rectangle boundary of the rectangle in the xy plane bounded by the lines x is equal to 0, x is equal to a, y equal to 0 and y equal to b. Solution. So first it is better to draw the region. Okay. So x is equal to 0 means y axis, x is equal to a, this is x equal to a. So this is y equal to 0, x axis, and y equal to b. This is the line y equal to b. So this is the origin O. So 0 comma 0. This is a point A. X is A, y is 0. So A comma 0. And this is B. Okay, this is B. X is A and y is B. This is A comma B. This is a point I will take C. C. Okay, I will write here. Okay, C is 0 comma B. So it is one more thing in the curve C. Okay, closed curve C. Okay, is in the anti-clockwise direction. So you should mention the direction of C to be in the anti-clockwise direction. That is important. Okay, this is your C, closed curve C. Okay. Now I'm going to evaluate the right hand side of the Green's theorem. So first write the Green's theorem. By Green's theorem, let's write the statement. C pdx plus qdy, okay, is equal to double integral over r. Okay, dou q by dou x I will write in the short form qx, and then dou p by dou y I'll write in the short form py. Okay, so you better to write dou q by dou x and dou p by dou y. Okay, now we know that p is what? P is x square minus y square, because p dx. This is p. Q dy. Q is 2xy. So we have p equal to x square minus y square. Okay, so this implies dou p by dou y we need. Okay, dou p by dou y equal to minus 2y. Similarly, q equal to 2xy. So dou q by dou x, you get 2y. So right hand side of Green's theorem is double integral qx is 2y minus py, dou p by dou y. So minus of minus, okay, I'll write minus 2y, okay, into dx dy. Now here, suppose if you write here dx, so it is better to write here x, and here you can write y. Here all the limits are constant, so the order of integration is immaterial. So what about the limits for x? Can you tell? X varies from where to where?
0 to
0 to a. Yes, correct. Dikshita. What about y?
0 to b.
Yeah, 0 to a and 0 to b. So you can easily check it here. X varies from 0 to a, okay, and y varies from 0 to b. So if you write dy dx, and then if you should write here y equal to 0 to b, here you should write x is equal to 0 to b. So now 0 to b, 0 to a. So this is actually x. Okay, so 4y dx dy. So first you should integrate with respect to x. Keep y is constant. So actually 4 is constant. That's why I will take it out. So 4. You should keep y is constant now, because you are going to integrate with respect to x. So if you integrate dx, you get x. Limit is from x varies from 0 to a into dy. So if you 4 times this is actually, if you apply the limits, you get what? A minus 0. A minus 0. So that's why I'll take a outside the integral, because a is a constant. Remaining you have 0 to b y dy. So which is equal to 4a into integration y dy. If you integrate y, you get y square by 2. Limit is from 0 to d. So 2a by 2 is 2. 4a by 2 is 2a. Upper limit is for you'll get b square minus 0. So finally you'll get 2a b square. This is the answer for the right hand side. So suppose the same question is asked in the exam. Okay, so instead of asking verify Green's theorem, suppose if they are asked use Green's theorem, instead of verify, use Green's theorem in a plane to evaluate this integral. The region is everything same. Then it is by using Green's theorem, the left hand side integral is equal to the right hand side. So and hence only the right hand side is enough. We can stop here because this value is same as we are using Green's theorem. So that's why we easily got the value. Suppose if they ask verify means you should find the left hand side as well as right hand side, and then you should prove both of them are equal. Okay. So next left hand side. Left hand side equal to I think we know that the statement of the Green's theorem tells C pdx plus qdy. Okay. So C, you can see divide C into 4 parts along OA, AB, BC, CO. So OA. Okay, well, what is the pdx plus qdy in your problem? You have x square minus y square into dx plus 2xy into d. So along OA, the equation of the line OA is y equal to 0, and the dy equal to 0. Okay, this is the equation of line OA. Similarly, plus integral next AB along AB. What is the equation of the line AB? X is equal to A. X is equal to A. So dx is equal to 0. Okay, so we should write again the same integrand square minus y square into dx plus 2xy into d. And third, along BC, along BC, okay, along BC. So in BC you have a equation y equal to b, dy equal to 0, because y equal b is a constant. Okay, and the integrand is the same. Okay, so it is better to write. Okay, I will write here x square minus y square into dx plus 2xy into d plus integral. Direction is important. Okay, CO. Don't write OC. Similarly, don't write here CB. So direction is here important. So CO, x is equal to 0, dx is equal to 0. Again, x square minus y square into dx plus 2xy into dy. Okay. Is Aditya is here? Aditya? Okay. What about Manigandan?
Yes, sir.
Okay. So now I need your help. I'll go to the next slide. Just to substitute and tell the answer for each of the integral. So please do.
Uh, Integral x
Integral
square
uh,
dx.
x square dx. Okay.
Yes, sir.
Uh,
Plus integral
uh,
a square minus sorry
uh,
2ay dy
2ay dy.
plus integral
Integral
uh, x square minus b square dx
x square minus b square into dx.
plus integral
Uh,
uh, zeros.
yeah, correct. So we can verify once again. Okay. So if y equal to 0, dy equal to 0. So dy equal to 0 means y is 0, dy is 0, this is 0. And y is 0 means this is also 0. So you have only x square into dx. Okay, you can check it. X square into dx. Okay. And along OA, x varies from where to where? Please see the diagram and tell what is the limits. X varies from
0 to yes.
0 to a. Okay, so next second integral. dx 0 means this part everything is 0 and x is equal to a. X is equal to a means 2a y into dy. 2a y into dy. And we are in AB, okay, along AB. In AB, but here the integrand is y. Y varies from where to where, Yashashwini? The line Yashashwini is here.
0 to B.
0 to B. I'll check it. Yeah, 0 to B is correct. Check your internet connection. The voice is not clear. And the third integral, okay, we'll check the third integral. dy 0. dy 0 means this is 0. Y equal to b. Y equal to b means x square minus b square into dx. X square minus b square into dx. Okay, and along BC, I have the variable x only. X varies from where to where? Vigneshwar. Along BC. Vigneshwar, Kirtana.
Sir,
Along BC, x varies from where to where?
it's constant. 0 to A, sir.
0 to a சொல்லுவீங்கன்னு தெரியும் எனக்கு. அதனால தான் டைரக்ஷன் போட்டிருக்கேன். சரியா? டைரக்ஷன் போட்டிருக்கேன். அதனால should tell a to 0. Okay, correct. A to 0 is correct. Okay. So a to 0. And last one is x is equal to 0 and dx is equal to 0. So dx is equal to 0 and x is equal to 0. So that's why it is final answer is 0. The remaining part is just integration, single integration, x cube by 3. Okay, so limit is from 0 to a and 2a into y square by 2, 0 to b. Okay, and then if you integrate here, x cube by 3 minus b square x, limit is from a to 0. So upper limit is a cube by 3, lower limit is 0. Plus 2 gets cancelled, a into b square minus 0. Okay, plus here the upper limit is 0. Okay, minus a cube by 3 minus b square into a. So finally you'll get a cube by 3 plus ab square minus a cube by 3 plus ab square. So a cube by 3 gets cancelled. So finally you'll get 2ab square. This is actually left hand side. So left hand side is equal to right hand side, and we verified Green's theorem. Okay. The second column. So in this first column, the region is simple. It is a rectangle region. The second column, verify Green's theorem. In a plane, for integral over c over c 3 x square minus 8 y square into dx, okay, plus 4y minus 6xy into dy, where c is the boundary of the region. C is the boundary of the region. Defined by the lines x is equal to 0, y equal to 0, and x plus y equal to 1. Okay. So first step, you should draw the region. So this is actually, you know that y equal to 0. This is x is equal to 0. X plus y equal to 1. Okay. So how the lines, how the line path is x plus y equal to 1? How to draw?
Substitute x equals to 0 and y equals to 1.
Okay.
And y equals to 0, x equals to 1. So it comes like a slope.
Yeah, it's looking like okay. It's correct, Kitna. So this is line x plus y equal to 1. So this point is origin. Okay. O, that is 0, 0. This is the point I will take A. A is x is equal to 1. Okay, because this is x plus y equal to 1. Yeah, y is 0. Y is 0 means x is equal to 1. This is the point I will take. B. B is x is equal to 0 and y is 1. So this is your region R. This is the triangle region. Your C is, this is your C. Okay. This is your C. Okay. Now, right hand side. So right hand side of the Green's theorem is equal to double integral over R qx, okay, right, dou q by dou x. So I think you know the method now. So now without my help, you can do. So try and get the answer. And if you get the answer, you can tell and you can verify. Okay. Now what is p? P is 3x square minus 8y square, and the q equal to 4y minus 6xy. I need dou p by dou y. Dou p by dou y is minus 16y, and then dou q by dou x. It's 0 with respect to x means minus 6y. So the right hand side equal to double integral q x, that is minus 6y, minus of minus plus 16y, yeah, minus 6y plus 16y into dx into dy. Okay, now the question is limits. Okay, so x varies from where to where? Pragadish?
Yes, sir.
Yeah, please tell here dx dy. Okay, x varies from where to where? The
0
data.
to 1 minus y, sir.
Yeah, 0 to 1 minus 1. If we take a strip parallel to x-axis, okay, here x is equal to 0, here x is equal to 1 minus y. Okay, so x is equal to 0 to 1 minus y. Okay, and you should move the strip from this line. Okay, so horizontally you should move. Okay, if you move, then y varies from where to where? Jagdish?
Yes, 0 to
Yeah, 0 to okay, 0 to 1. The reason is okay, here okay, here x is equal to 0 to x is equal to 1. Sorry, x is equal to 1 minus 1. And you should move the strip. Okay, initially the strip is here, and then you should move the strip horizontally. Then okay, then only you can cover the whole region R. Okay, if you move the strip, y varies from in this line. Okay, 0 to what? So
yes, sir.
okay, so y. Suppose if you take a strip, if you okay, the integrand is same. Okay, dy dx. Dy dx means here y, here x. Then you should take a strip parallel to y axis. Parallel to y axis. Here y is what? Y is 0. Y here y is what? 1 minus x. Y equal to 0 to 1 minus x. Okay, you are taking a strip parallel to y axis means you should move the strip like this. Okay, you should move the strip like this. So x varies from 0 to 1. So both answers are correct answer. You can check it later. So now I am going to do like this. So this is 0 to 1, 0 to 1 minus y. So 10y, yeah, 10y into dx into dy. So 0 to 1, if you integrate with respect to x, keep y is constant. 0 to 1 minus y into dy. So 10 into 0 to 1, y into upper limit is 1 minus y, lower limit is 0 into dy. So this is equal to 10 into interval 0 to 1, y minus y square into dy So this is nothing but if you integrate this, you get y square by 2 minus y cube by 3. Limit is from 0 to 1. So 10, 1 by 2 minus 1 by 3. Upper limit. Lower limit is 0. So 10. If you take 6 is LCM, you get 3 minus 2. 3 minus 2. So 10 by 6 is 5 by 3. So this is right hand side value. Now we need to calculate the left hand side. LHS equal to, I should split into 3 integrals. Okay. Originally it was what? Integral over C, 3x square minus 8y square into dx plus this is the given problem I am writing. This is a pdx plus qdy. Okay, now I should split this into along OA. Okay, along OA. So next plus along AB plus along BO. Along B. Okay, so along OA, so okay, you can write along OA, y equal to 0, y equal to 0 and dy equal to 0. Okay, similarly along AB, x plus y equal to 1, x plus y equal to 1. So this implies x is equal to 1 minus y, or you can write y equal to 1 minus x. X is equal to 1 minus y means dx is equal to minus dy. So everything you should write here. And then BO. BO is what? BO is x is equal to 0 and then dx is 0. So you should write here 3x square minus 8y square into dx plus 4y minus 6xy into dy. Here also you should write the same thing, 3x square minus 8y square dx plus 4y minus 6xy dy. Same integrand, 3x square minus 8y square into dx plus 4y minus 6xy into dy. Okay. Now, so it is better to evaluate one by one. So first evaluate, I call, okay, I think you can do simultaneously, no problem. Okay, so maybe in the next problem you can do separately. If you want, this problem also you can do it separately. First we calculate this and then we calculate this and then we can calculate this. So this is equal to Subramaniam.
Yes, sir.
Please substitute and tell the values. Okay, when y0 dy0. Okay,
Integration of
integration of
3x square dx.
3x square dx. Okay, plus கொஞ்சம் கேர்ஃபுல்லாக சொல்லணும். ஓகேவா?
Yes, sir.
Yeah, actually 4 this is 0 this part is 0 first integral. because dy is 0, this is 0.
Yes, sir.
Y is 0, this is 0. So only you have 3x square dx.
Yes, sir.
Okay, what about the limits?
0 to 1.
Yeah, 0 to 1 is correct. Because along OA,
Yes.
okay, along OA, yeah, along OA, 0 to 1. Okay, correct. Next integral. So second integral here nothing is 0. So you should
Yes.
convert everything in terms of
Y.
either x or y. Here it is better to write in terms of y. So
Yes.
3 into what?
1 minus
1 minus
y the whole square
that is x square is 1 minus y whole square. Okay,
minus 8y square
8y square. Okay,
into dx
dx is what?
minus dy
Yeah, minus dy
plus 4y
plus 4. Okay, I will write here 4y
minus 6
Min-
into
uh,
y
X.
into 1 minus y.
y into 1 minus y. Okay, 6x x is 1 minus y. Yeah,
Yes.
into
Into
y into dy.
dy.
Okay, correct. Here everything is in terms of y, and then you are the AB, yeah, AB,
4y dy. Okay.
AB. What about y? Y varies from where to where?
1 to 1, I mean 0 to
Ah,
1 minus x.
in the line la. Okay, so
Okay,
you are-
sir. 0 to 1.
yeah, 0 to 1. That's all. 0 to 1. Because you are moving from OB. Okay, y varies from 0 to 1.
0 to 1.
Yeah, y varies from 0 to 1. Okay. Finally, you have last integral is what?
4y dy.
4y. Okay. What about y varies from where to where?
1 to 0, sir.
1 to 0. Very good. Thank you, Subramaniam. So if you have any doubts in these three integral, you can ask to me. If you have any doubts. Okay. Now, remaining part is just a calculation. Okay. So, the first and the third integral is a little bit easier. So, first integral is what? 3 into x cube by 3. Limit is from 0 to 1. Okay. Now, simplify the second integral. So 3 into a 1 minus y, a square b square minus 2y, okay, minus 8y square into minus dy plus 4y minus 6y plus 6y square into dy. This one is 4 into y square by 2. Limit is from 1 to 0. So 3 gets cancelled. So 1. Okay, 1 minus 0 is 1. And the last integral, I will evaluate the last integral. So 2 plus 2 into 0 minus 1. So last interval is also over. Only we should concentrate about the second integral. Okay, second integral. So 3 plus Karthikeyan, please multiply and tell. Karthikeyan, 3 plus 3y square. Sorry. Minus 6y minus 8y square Okay, okay, minus dy, yeah. So I will take minus commonly here. Minus, okay. Uh, so keep minus dy, and then uh, here 4y minus 6y plus 6y square plus 4y minus 6y, sorry, 4, that is minus 2y, yeah, 6y square minus 2y, 6y square minus 2y. To dy. So this is equal to 1 minus 2 is minus 1 plus integral 0 to 1 multiplied by minus sign. So minus 3y square plus 6y plus 8y square plus 6y square minus 2y into dy. So which is equal to minus 1 plus 0 to 1. So how many y square? 14 y square. Okay, 14, no, 14 minus 3, 11 y square. Okay, and then 6y minus 2y is plus 4y minus 3 into dy, which is equal to minus 1 plus, if you integrate 11 y cube by 3 plus 4 plus 4 y square by 2 minus 3y. Limit is from 0 to 1. So it is equal to minus 1 plus upper limit is 11 by 3 plus 4 by 2 is 2 minus 3. Lower limit is 0. So 11 by 3 minus 2, which is equal to 11 minus 6 is 5 by 3. So 5 by 3 is the final answer. So this is the left hand side. So we know, I think right hand side is also, we got the same value, 5 by 3. So left hand side is equal to right hand side, and hence we verified Green's theorem for this problem. The last problem, I'll choose a simple problem. Okay, so use Green's theorem in a plane, not verify. Okay, use Green's theorem in a plane to evaluate integral of the closed curve C 2x minus y into dx plus x plus y into dy, where C is the boundary of the circle of the circle x square plus y square equal to a square in the xy plane. So I am expecting the final exam, the semester exam, Green's theorem and Stokes theorem and Gauss So in each theorem, I am expecting one question because the last unit, so they should ask two questions. So subdivision A, so 4A, 4B, or something like another AB. So that so there is no other choice in the last unit. So you should concentrate more on these three theorems. Okay, now by Green's theorem we have over C PDX plus QDY is equal to double integral over R dou Q by dou X minus dou P by dou Y into dx into P. So we know that P equal to what? P equal to 2x minus y. If anybody got the answer, you can tell. I'm waiting for your answer. Dou P by dou y. Minus 1. Q equal to x plus y. X plus y, it is dou Q by dou x is also 1. Yeah. So by using Green's theorem, we have integral over C, closed curve C. Yeah. C 2x minus y into dx, that is a pdx plus qdy, which is equal to double integral qx. Qx is 1 minus of py is minus 1 dx dy, okay, over the region R. Okay, so this is actually 2 times dx dy. So the region R. Here the region is, it is given the question. The region is the circle x square plus y square equal to a square in the xy plane. Okay, so that means, so imagine it is a circle. Okay, so this is centered at origin. The radius is a. So what is this? What is this?
Yeah, circle.
Very good. So I forgot. So please tell your name.
Sanjay, sir.
Sanjay. Very good. Area of a circle. Okay. Wow. So this is equal to 2 into. So double integration means area dx dy. Double integration dx dy means area of the particular region. So here the region is the circle. Okay, so area of R. Area of the region R is equal to 2 into pi a square. Area of the circle is pi a square. So we got the answer. So I stop here, and we'll meet on 4th hour. So I tried to complete Green's theorem today itself. Okay, thank you. If you have any doubts, you can ask to me. Otherwise, we'll meet again 4th hour. Thank you. Thank you, everyone.
Thank you, sir.
Thank you.
Thank you, sir.
Thank you.
Thank you, sir.
Thank you. Thank you.
Thank you, sir.
Thank you. Thank you.